Welcome to week 8 of the processing course. This week we're going to dig into one very big topic and also cover some odds and ends. We'll start by looking at how to organize a big project. Basically, we just break it up into files. They're all stored in the same folder, and they show up in the processing window as separate tabs. This makes it very easy to organize and manage a big project. Then we'll dig into the big topic this week, objects. Using objects, we can create our own new types of variables, and they can be very big and very interesting, like, say, airplanes. The basic idea is that every airplane is an instance of the same object. Every airplane is identical to each other, but it has its own variables that tells it things like where it is, where it's heading, and how fast it's moving. To control an object, we send it a message. And so there's a technique for sending messages to objects. The objects receive the message and act in response to it. This is a great model because it really matches the way we think about things in the world. Sending a message to an object is very easy. We just name the object, we include a period, and then we send it the message we want it to respond to. To illustrate how to use objects, we'll use a running example of a car. Each car is described by a bunch of variables, and there are a bunch of messages, also called methods, that it knows how to respond to. We'll see how to organize these in processing. It's very easy. We just say class car at the top with an open curly brace, and then we list the variables, something called the constructor, which is the way we make a new car, and the methods, that is, the messages we can send it. Here's an example of a bunch of moving cartoon cars. I can select one of the cars and send it one of a number of messages, like turn left or turn right, or speed up or slow down. We'll see that one of the great advantages of organizing our code as objects is that we can then tell the objects to change themselves. Here, I'll tell every object, instead of drawing itself as a little cartoon, to use a little photograph. And here's the result. My main program didn't change at all. The objects are responsible for everything they do, including drawing themselves. So this was a very easy change to make. In this sketch, I'm drawing a field of arrows. Each arrow is its own object, and it's trying to follow the mouse, which is the little yellow dot. The arrows are color-coded. When they're pointed away from the mouse, they're orange. When they're pointed at the mouse, they're green. And the big arrows turn more slowly than the small ones. Because our arrows are objects, I can change how they respond to messages. In this case, I'll change how it responds to the message, draw yourself. I took a little videotape of myself opening up my hand from a fist into a pointing finger, and I saved the frames of the animation as an array in processing. Now, as the hand turns, I just choose a different image out of the array. We say that each of these objects is described by a class, and one of the great advantages of using classes is that we can have subclasses. That is, we can take something like a black and white TV and extend its capabilities, inheriting everything the black and white TV can do, but then giving it more, like color. Then we can take the color TV and extend that. So our new object, an HD TV, can do everything a color TV can do, and even more beyond that. To illustrate that, I'll create a little aquarium. Here's a bunch of fish swimming back and forth. Let's make this more interesting. So in addition to my fish tank class, which makes an object, and my fish class, which has made all the objects we just saw, I'll create 3 subclasses, 3 things that are built on fish and extend its capabilities. A hungry fish, a sleepy fish, and a light fish. The idea is that the light fish is delicious, and every hungry fish wants to eat it. The sleepy fish, they don't care. By building these fish, I can populate my fish tank with lots of interesting fish. But here again, we can take advantage of the beauty of objects. When any of these fish hit the edge of the fish tank, or the hungry fish needs to follow the light fish, I send it the message to turn around. If I change the way the single fish object works, the one that they're all built on, and I have it turn around in a nicer way, they all inherit that motion. So here I have 3 different kinds of fish, but I didn't touch them at all. I got nicer behavior just by changing the class that they're all built on. So we'll look at all this object stuff closely, of course, and you'll be a master of it all. Now, we'll turn our attention to some of the odds and ends I mentioned. For example, how would you go about doing this? Here I have a stencil with 4 big circular holes moving over the surface of a photograph, and using my keyboard, I can change the radius of the holes or even the radius of the whole stencil. This would be very hard to do using the techniques we've seen so far because you'd have to build up this stencil out of just a gazillion little pieces. There's no good way for cutting a hole in something. But this is easy if we use a technique called off-screen buffers. So I'll show you how to do that. Then we'll take a look at how to find the current time and date. Of course, once we know the time, we can draw a clock, but there's no need for us to draw traditional clocks. We can draw clocks that work any way we want. Here's a clock that has 1 dot for every hour. The dots start out in a nicely organized colored pattern, but as the hour goes on, they fall to the ground in a jumbled mess. We can also get the date from the calendar. This wiggly line represents a year, and the little circles indicate the start and end of every month. The big yellow dot, that's today. And it's not just today, but it's today and right now. So conceptually, that yellow circle is moving every second, crawling along that line from midnight of January 1st on the far left to midnight of December 31st on the far right. It's often very useful to be able to read and write text files because you can store tons of information in a text file and easily change it. So we'll look at how to read in the XY coordinates for an object, like a bear, from a file on the left and turn it into a floating point array on the right that we can then use inside of our code to draw with. We'll also see how to go the other way and take information from inside our processing program and write it out to a text file. From there, we'll turn our attention to 3D. Processing has some basic 3D capabilities, and while it doesn't come close to rivaling the big 3D packages, it can do some pretty nice stuff. We won't go into the details of 3D because it's really an advanced topic, but I'll give you the overview of the process and show you a couple of examples of things you can do. Finally, we'll look at a few ways that you can share your program once you're done. We'll see how to export your program as a standalone application, just like any other program on your computer, so you can share it with friends and they merely need to double-click on the program and it runs. They don't need to have the processing environment at all. Alternatively, you can save your sketch so that you can load it in a browser page. And now your sketch can run on any computer that has a web browser. We'll also look at how you can save your sketch for mobile devices like smartphones and tablets, and even how you can download it onto a little one-board computer so that you can create completely standalone computers that run your processing code. Finally, we'll look at where you can go from here. We'll talk about ways that you can extend what processing can do, and then we'll talk about how to extend the range of what you can do, so the breadth and depth of your processing projects will grow every day.